Okay, so for section 3.2, we are going to continue with the right triangle trigonometry. But what I want you guys to notice is that we are going to be looking for a missing angle, but, not a missing angle, a missing side, but instead of being given two sides and you find that missing side, you are only going to be given one side, okay? And so we are unable to use Pythagorean theorem when that's the scenario, okay? Pythagorean theorem requires that you have two sides, whether it's two legs and a missing hypotenuse or a leg and a hypotenuse, find the missing leg. You always have to have two to find one missing, okay? So here is where the scenario is going to change, because now, as in the first example, you can see you are only given one side length and they're saying, hey, go find the other one. Okay, so Pythagorean theorem out the window, can't be used. Okay, so what we're going to do is see how we approach this when we have special right triangles, and there are two scenarios for special right triangles and only two. So if you recall from geometry, one of the triangles is going to be the one that is a 30 degree, 60 degree, 90 degree triangle, or the other one is a 45, 45, 90 degree triangle. Notice that the angles all add up to 180. Any other type of combination, you will learn how to do those type another day. Okay, so these are why these are called special right triangles, because this is the only combination that this approach can work for. Okay. So one of the first steps to working out these problems is you looking at the diagram that's provided and telling yourself, okay, am I going to work with this as a 30, 60, 90 or as a 45, 45, 90 triangle, all right? We're going to jump around this worksheet because I preferred a certain order to the one I put here. Like, I created this and then I didn't like the order, but I didn't want to recreate the whole thing. So we actually are going to start with number 6. All right, so if you would flip over to number 6 and bear with me as we jump around this worksheet. We're not going to do all 8 unless I sense that this class needs it, but you guys are my last class that I'm teaching this to, and it's been pretty straightforward that nobody needs all of them. So number 6, here's how you guys approach this. So if you look at the picture, we right automatically can tell that they want us to use a 30, 60, 90 because it's obvious, because it's already labeled for us, okay? So what I want you to do is come over here and label on a row what the degrees are of your given figure. Okay, so you're going to write 30, 60, 90, identifying it to yourself as, okay, I'm working with a 30, 60, 90 triangle. On the next row, right below 30, 60, 90, you are going to write down the ratios of these angles. Now, I'm going to write these down and you follow with me, and then I'm going to tell you something. So m squared root of 3, and 2m. So write those down and then I'll explain what these are. m squared root of 3, and 2 times m. M stands for measurement, okay? Now, if you are one to ask where are these numbers coming from, these are the given ratios for the 30, 60, 90 triangle. There is a proof that is done to show you where these numbers come from, but for on-level pre-calc, we don't go through that proof. For honors, that when I taught honors, I would go a whole day showing you guys with cutouts and everything, hands-on activity to show you where these numbers come from. I can show you on your own individual place if you are interested in where these numbers are coming from. If you're like, it's okay, I need you just to know that these are the ratios, okay? So for 30, 60, 90, all I'm saying is, for instance, what does this mean? If the side across from 30 is length 5, I can automatically know what the side length across from 90 is going to be, because if this is 5, this one has to be 10, and then the one across from here would be 5 square root of 3. If I know this is 20, then the side across 60 is 20 square root of 3, the side across 90 is 40, and so forth. Those ratios are fixed. They do not change. So you will eventually have them memorized. Okay? Are we good? Yes? Okay. So, next step. So that's what you do first. Identify the triangle, write down the ratios. That's the first two steps. There's no thinking going on there. You guys are just following procedure. The first step that you are actually going to do somewhat of thinking is you're going to write down where your given information is. So you were given a length of 9. 9 is across from 30 degrees. So I'm going to want you to put that given information under the column that says 30 degrees. So I'm going to place my 9 under 30. They wanted us to find x. X is across from 90 degrees. So I'm going to put my x value, which is what I'm looking for, underneath the 90 degrees. Okay. And then the other missing one, they're not asking us to find it, so I'm just going to leave it blank. Okay? I'm not going to worry about it. If they were asking you to find that other side and labeled it y, you just put y right here. Okay? But we don't need it. So what do we do once we have this organizer? This is just a visual organizer to help you get started. You have two equations to compare. You have an m equals 9 and a 2m equals x. I want you to always start with the equation that does not have the x. Okay? This one has an x, so I want you to ignore it. So what I mean by that is you take those two values and you set them equal to each other. Number 6 is the easiest problem, so you're going to see that there's not much work. So take the one without the x, the column that has no x's, and take those second row and third row and set them equal to each other. So I got m equals 9. So my measurement for this triangle is length 9. And then I'm going to go over to the other equation, which was this one, 2m equals x. And I'm going to substitute what I found in the first equation. We found that m was 9. So I'm going to replace this m with a 9. And my x is 18. And then I'm done. You will type 18 in your Delta Math and be done. Okay? So, procedure-wise, are we so-so? We okay? All right. Okay, so silence means yes, and those that shook their heads and acknowledged, I appreciate it. We're moving on. If you don't understand, then you need to speak up. So go now to problem number 2. We're going to get a little bit harder, okay? Because that wasn't hard, so we're going to do here. So I want you to do this one for me. Set up your little organizer based on how we just did this one. So on your first row, write down your angles, your angle measures. Your second row, write down the ratios. Those are not going to change. And then on the third row, write down the two givens. Write down where they are across from. All right, so let's see here. Emma, tell me where you put the 4.
I put the 4 under 90.
4 under the 90. All righty. And then let me see, Nathan, where did you put the x? X under 60. Okay, so there's the setup for everybody. Okay, again, you have to make a choice on which one you're going to start with. Are we going to start with the left or with the right equation? The one without the x, right. Very good. So I heard the explanation and I heard some people say right. So you start with the one without the x because you need to solve for m first. Solve for the measurement first. So 2m, set it up, 2m equals 4. Is m isolated yet? No, not like the first problem we did. M was already isolated. What do I need to do to both sides? Divide by 2. So now I found what m is. And so Once I find m, now I can go to the other equation that I ignored and set it up so that I can substitute. Okay, so substitute m into the other equation. M is 2, so I literally just put the 2 in for m. There's nothing else you need to do. You're not going to multiply 2 times square root of 3. You'll get a decimal. So you just stop there. And so the length of this side across from the 4 here is 2 square root of 3. Okay. And you already knew that this one here would be 8. Or 2, sorry. All right. Still no questions? All right, we move on to number 3. So sometimes they're gonna give you not a triangle, but triangles embedded in a polygon, okay? In this particular polygon, we have a square. Now, in that square is our triangle or our triangles. Are they 30, 60, 90 or 45, 45, 90 triangles? They're 45, 45. Very good. We know all these angles are what?
45.
What?
Or 90.
They're 90, right? Everybody see that? So we have, if you recall from geometry, this is a bisector, okay? And that bisector cuts our 90 into 45s. So here's that 45, 45, just in case somebody was like, I don't see how they knew it was a 45, 45, 90. Okay? So here is the ratio for those, because we haven't done one of these yet. So we still are going to write down our identifying triangle. But now what you are going to write down are your ratios. The ratio here is going to be m square root of 2. So instead of m square root of 3, 2x, it's m square root of 2. You are still going to put the given information under the correct column. That's not changing. So square root of 8 is across from 45. You can put it on either one, it doesn't matter. And x is across from my 90. The process still stands. Pick the equation where you will solve for m first so that you can get an answer to substitute into the other equation. So with that being said, we would start with m equals square root of 8. But we notice, happily, do we have any solving to get done here? No. Do we need to divide both sides by anything to solve for m? Nothing. So we're good, right? M is solved for, so we're done. So what we do is go find our other equation, set it up, and we plug in that m. So I'm going to plug in m, substitute square root of 8, bring down square root of 2, and simplify if possible. Okay. Since both of these numbers are radicals, you can simplify. What I mean by that is if you were doing 8 times square root of 2, you would stop. You wouldn't do anything else. That's a whole number, that's a radical, you can't go any further than that. But since they're both radicals, you can multiply and put the answer underneath the radical. What answer is that going to be? 16 is correct. Okay? And then you decide if your answer stays like this or can it be simplified. Can you simplify square root of 16 to what? Another one. 4. Yeah, because this one's a perfect square, right? It's a perfect square. All right, there's our x. Okay. So far good? All right, second to last problem coming up. No questions so far. Okay, let's up it a notch. Number 4 and 5, the fourth and fifth problem that we're going to do are the hardest it gets. It doesn't get any harder than that. And then the remaining questions we don't do, I'm going to post the notes on Canvas so you can get the answers to those if you want to work them out on your own and check yourself, okay? All right, so number 1, go ahead and set it up for me. And let me show you what the little extra rigor comes in. It's just some solving stuff. All right, so check your setup. Okay, so at this point we are setting m squared to 2 equals to 9. Okay. All right, so what are we going to do to both sides now? If we want m by itself. Very good. Divide both sides by square root of 2 so I can get that m all by itself. Okay. Now here's where I want you guys to notice is where your work comes. You already finished your m, and usually when you have your m, you go straight and go substitute it over here. But what I need you guys to do first is actually simplify this some more. If you notice, and I'm purposely doing it in red, so if you guys have a highlighter or something, they want you guys to not have denominators that are not rationals, okay? And right now, rational means no square roots as denominators, okay? And right now, your square root of 2 is a problem, okay? So I'm going to write down this answer here because I want to prove a point to you guys, okay? 9 times the square root of 2, no, sorry, 9 divided by the square root of 2 is this value, 6.4 approximately, okay? So keep that in mind because I want to show you guys what I'm trying to tell you to do. So basically this is what's happening. If we're talking fractions, if I gave you 4/8, this is correct, but what they're asking you to do is write the simplified format of 4/8, which is 1/2. This has to do with fractions, okay? They don't want you to put 4/8 into the Delta Math answer. They're like, you can still simplify it some more. So 4/8 reduces to 1/2. Do you agree? Aren't those two numbers still 0.5? Okay. It's the same thought process with this. They're like, okay, yeah, you got it, but we don't like square roots in the denominators. They want you to rationalize. They want you to get rid of that denominator. So the step I'm getting ready to talk about is called rationalizing, okay? The way you do that is you want to rationalize to get that square root of 2 to become a whole number. By doing this, you will be able to get rid of that square root. Whatever you're trying to get rid of, multiply top and bottom by that radical, okay? And what's going to happen is the following. So if I multiply 9 times square root of 2, I'm just going to put them side by side because they are not like terms. I just put them right next to each other. But square root of 2 times square root of 2, those both are like terms. So I can multiply them and put their answer underneath the radical. But guess what? Square root of 4 is what? It's a 2. So what you ended up doing is rationalizing. You forced the square root of 2 to become a whole number 2. There's no more radical. If you are doubting if your answer is correct, you can type your rationalized answer. So alpha y equals 9 square root of 2 over 2, and double check to make sure that you did find the correct rationalized fraction. Okay? So always know that you can use that calculator to double check if you are like, I'm not sure if I did this correctly. Okay? So if you had a square root of 3 here, square root of 3, square root of 3. If you have a square root of 8 here, square root of 8, square root of 8, and so forth. Does everybody understand how to rationalize? Yeah? Okay, so now that I have m, my other equation said m equals x. So 9 square root of 2 over 2 is my x, and I'm done. All right, one more, then it's your time. We good? Yep, okay, here we go. Number 8. Set it up for me. Alright, there's our setup. So we start with the column with no x's, and we set them equal to each other. So here's another scenario that happens, and I wanted to show you guys that you have the green light to be able to do this if you ever come across a problem like this. So as you know, just like all the problems you've been doing up till now, you'll divide both sides by whatever's multiplying by your m. Okay? When you get to scenarios like this, sometimes what students do, because they're very quick to rationalize, they don't realize that both of these numbers are radicals, and if they are, you are allowed to divide them if they are able to be divided by. So don't rush to do this if you know that these two can divide. Can square root of 6 divide by square root of 3? Yes, it can. They're both radicals, so you have permission to do that. So my m is just going to be what? Equals to what? Square root of 2. 6 divided by 3 is 2. Just don't forget to bring the radical over, and you're done. So now I can just go into my other equation where x was equal to 2m and just substitute the m I found, and you are done. Okay? So notice with those 5 problems that we did, the process is just repetitive. Set it up, put your givens around underneath the right column, because then it will mess up. Solve for m, then plug in m. Do that process over and over and over again. Just make sure when you guys are putting your answers in Delta Math that you have rational denominators. Are we good? Yep. Okay. So here's what I want you guys to understand, please. Okay.